Alright, so I have a copy of the same shape here twice, and we're looking at it in terms of what symmetries it has. Now this shape is interesting because it has no reflection symmetry, but it does have rotation symmetry. So how is it symmetrical? We have to be careful here because even though this triangle here is repeated 4 times, we can't simply divide the shape by 4, right? And say, okay, it has 90-degree rotational symmetry. We have to also kind of think about how these shapes are moving, right? So it's not always going to be as simple as dividing by the way a shape is repeated here to understand how it's being, or to understand what its rotational symmetry is. So let's take a look at this. If I rotate this shape 90 degrees, what happens? Let's just take a look at that. And I think you'll see what I mean. You know, just in an intuitive sense here, let me try and get it not exactly 90 degrees. Oh boy. Oh, wait. Okay. Should be able to just type this in. Well, 91's pretty close, and you can see that in fact it's not symmetrical. I had to look at it for a second there, and the reason why is because of the color scheme of the inner square. Notice that the color scheme is off by 90 degrees, and that's our giveaway. Right here, I notice, in fact, you have to rotate it 180 degrees in order to get a match, right? Because every 2 of these tiles in the middle square actually repeat. So let's just keep rotating this shape here. We're going to rotate it 180 degrees. So now we rotate it 180 degrees, and then we have our match. And I guess if you're thinking, well, wasn't that, how can you keep track of this rotation? What I often do for myself is I kind of draw a line as a starting point. And then I think, okay, well, if I pick a point somewhere, let's say at this point right here, how far did I rotate it in this process? Well, I have to go all the way here, right? And every point will have to do that in order for the shape to actually rotate until it looks identical. And that's the 180-degree rotation. So you might keep track of a certain point, or the tip of this triangle, to see how it's actually being rotated and how far you have rotated it, right? So maybe mark a point or as a reference as you're doing these problems that'll really help. And of course, look into more sophisticated techniques as we move on. But here we're just intuitively looking at all these shapes to see what's happening. Now again, we have no reflection symmetry here, but we do have rotational symmetry. And in fact, in this one, you might see, because the color scheme's so uniform, right, and because there are 4 repeated rectangles and these pieces of curved pieces right here, we have a simple 90-degree rotational symmetry here. So just take this shape, got most of it there, and I'm trying to rotate it now 90 degrees, and there it is. And you can see that after rotating for 90 degrees, we do get a match. This is a little bit harder to see, but once you actually move it around, I think it's easy to see the match itself. So if you're dealing with a problem like this, it might be nice to actually, if it's in a book, you can turn the book 90 degrees to see what's happening. If we're unsure what that looks like, just remember that a 90-degree angle is a right angle, right? So that means a turn of 90 degrees, a turn of 90 degrees, right, would take any point on your shape, like this one right here, and then rotate it 90 degrees. So where would that go? Well, this point would come all the way up here. Right, that's a 90-degree rotation. I think you can see the connection right there. This point right here will get rotated right up here. And this point will get rotated right up here. And as we look more and more into these, you can see how these points and shapes are rotated. So again, to keep track of your rotation point, just pick a location, and as you turn 90 degrees, see where these things get mapped to understand what a 90-degree rotation looks like. All right, hope that helped.